Welcome all of you. So, continuing with the part of analytic hierarchy process. So, first we have seen like what are the multi-criteria decision making methods. Then we studied the AHP process in detail, like the process flowchart or the number of steps that are involved in this particular technique. And then we saw one example to illustrate how it can be used. Today we will see one case study again showing the application of AHP, so that all the concepts that we studied related to AHP are revised and you get used to solving the numericals based on AHP. So, let us take one case study of a municipal corporation which plans to develop a new sanitary landfill, and they must choose the best site among 4 candidate locations. So, there are 4 sites A, B, C and D, out of which a municipal corporation has to choose one. Now, if you look at this picture of a landfill, you can see it needs a huge land area, because it is not just the space for dumping the waste, but it also need lot of space for movement of vehicles, like especially trucks and JCBs, which are used to like dump or mix and turn the waste on a regular interval of time. Also, there is a limit on the height of the pile of garbage which can be attained. So, horizontally you need lot of surface area. So, there are 4 sites, and because the waste are being dumped and lot of waste would be biodegradable in nature. So, there will be lot of emissions also, okay. And when there are emissions, there will be foul smell or bad odor which can affect the communities living nearby, okay. So, the criteria that would be considered for choosing any site for something like landfill, one of the most important criteria would be how far is it from the human settlement. So, 5 important criteria that are considered for this numerical are: one is the distance from settlement, that is distance from community or human settlement, and far it is, better it is with respect to this particular criteria. More distance means the better. The groundwater risk, because of the leachate generated from the degradation of biodegradable waste, these leachate may percolate deep into the underground water and like spoil or contaminate the underground water, or even the surface water if there are surface like water bodies running in the nearby vicinity. So, the groundwater risk, so lower risk would be the better value. Land cost, obviously it is a huge amount of land, and the price of that land depending on whether it is agricultural land or like barren land, how far is it from the road and how far is it from the community, the prices would be different. So, land cost is a very important criteria. Accessibility by the road. So, if it is not, if it is in the middle of nowhere, then it will need the construction of roads also. So, how accessible that site is by road, because it will be mainly through the roads the transportation will happen for carrying waste from different wards of municipal corporation to that facility, the landfill. And last one is the environmental sensitivity, which will include all like emissions or like the effect on birds or nearby animals, biodiversity. So, sort of like summed up overall criteria of environmental sensitivity. So, these 5 criteria are there, 4 alternatives are there. So, if I have to revise for the criterias, like when we try to do the comparison or generate pairwise comparison matrix, the order of that matrix will be 5. It will be 5 by 5 matrix, because there are 5 criteria. And when we compare each of these 4 sites based on each criteria, so we will be getting 5 matrices of 4 by 4 order, because we will be comparing 4 sites amongst each other, okay. So, when we try to check consistency for this type of matrices, the random index here would be different, random index for 5 by 5 would be different. I think here it is around 0.89 and it comes out to be 1.12. So, we will see this in the numerical, okay. So, the data that is given to us for these 4 sites and 5 criteria, these are not the values, but these are the priorities or the importances based on the judgment of the experts or stakeholders or the data collected from different sources. So, it shows here clearly that highest weightage is given to the groundwater risk, followed by environmental sensitivity, then distance, and last cost and accessibility to the road. And under each criteria, the preferences of these 4 sites are given. So, like in criteria C1, distance wise D is best, groundwater risk wise B is better, and then for C3 that is land cost. So, 1 like site A, and here C4 site B, and C5 site 9. So, under each criteria a different site comes out to be the best one. So, we need AHP to solve a problem like this, where some of the criterias are quantitative, some are qualitative, okay, like these ones are qualitative, and these are the final data which is given to us. Now, solution. The first step in AHP is make a pairwise comparison matrix for the criteria. So, 5 criteria are given to us, we need to find which of the criteria is the most important. So, we will just prepare the 5 by 5 matrix. The first column is obtained from the data that we are given in the question. And how do we fill the rest of the column? Obviously, this one is a diagonal element 1 1 1. The reciprocal of these would be filled in the first row, and now these entries would be filled by shifting scales row wise. So, if it goes from 5 to 1, it is going 4 steps down. So, 1 by 3, 4 steps down, it goes 1 by 7. Here 1 by 3, here it should have been 1 by 7, but sometimes when we give human preferences or human judgments, it may not be so accurate all the time, but as long as it is in the similar direction, it is reducing. So, here it is reducing, the consistency level may still be acceptable. So, here because both of these criteria, land cost and access to road, they have same value. So, each of these values would turn out to be same then if we try to follow that. That is why we deliberately changed this to 1 by 5, and then when it increased, it also increases by the similar number. It need not be increase or decrease by the exact same number, but by similar value plus minus 1 or 2, it is fine, it is acceptable. And once we get this, you have the reciprocals of this. Similarly, you fill these values following the shifting of scales row wise, comparing here, and then you get the reciprocal matrix for that. Okay, the same with this number. So, once you do that, you get the 5 by 5 pairwise comparison matrix for criteria, 5 criteria. And now, next step is to find the priority vector or priority weights for each of these criteria. So, by approximation method, you take the sum of the column. Next step is you normalize each entry using this sum. So, 1 upon 9.66 will give you 0.1, 3 by 9.66 will give you 0.3. Similarly, 1 by 5 upon 1.8 will give you this, and you go on criteria. So, here 1 by 4.8 will give you 0.205. So, that is a normalized criteria matrix, the second step. Third step, to obtain the final weights would be take the average of each row. So, there are 5 entries. So, addition of these 5 numbers divided by 5 will give you the final weights of the 5 criteria. So, if you look at the weights, it is clear that number 2, the groundwater risk, is the most important criteria we having highest weightage of 48.8%, followed by environmental sensitivity. That is the second important criteria. So, if you look at the data given, you see 5 was given to groundwater, 3 is given to environmental sensitivity. So, we get the similar, like the weights trend is also in the similar way. Okay. Now, to check whether these weights are consistent or not, so consistency check is Ax equal to lambda x, where lambda is the eigenvector. So, A is matrix is 5 by 5, the original matrix which we prepared for pairwise comparison of criteria. X is the weights that we calculated. So, if you multiply this row by this column, you will get the first entry into the A by x, Ax product. Then second row into entire column will give you this value, third row into this, and you can do this like by using a calculator or by using Excel. In Excel, if you are summing, like multiplying and summing the matrix, you can use the command mult, okay, matrix multiplication, and you just give the array 1 comma array 2, okay, that will solve that will give you these numbers. So, once Ax is calculated, you equate it to lambda x. So, lambda would be 0.722 upon 0.136. So, it is 5.3. Again you will get 5 values accordingly. Now, this is a these are the eigen values. Now, to get the maximum eigenvalue lambda max, you take the average of it. So, average of these 5 values is 5.285. Now, once we get the lambda max, we can to check the consistency, we need consistency ratio, but for consistency ratio we need consistency index. Consistency index is lambda max minus n by n minus 1, n is 5 in this case. So, it will be lambda max minus n. So, 5.285 minus 5 upon n minus 1, 5 minus 1. Okay. So, it will be something called 0.285 by 4. So, it is 0.07, 4 into 7, 28, right. And random index for 5 by 5 matrix is 1.12. This is typically given in the numerical, you do not need to memorize this value. You divide this by 1.12, you get something called as 0.06, which is less than 0.1. So, consistency is acceptable. Okay. So, the criteria weights that we got, they are acceptable. That is what is the first step. And the second step would be to calculate or to evaluate alternatives under each criteria using the same procedure. So, second step is alternatives pairwise comparison matrix for each criteria. The first, let us take C1, distance from settlement. So, we will get matrix of 4 by 4 because there are 4 sites A, B, C, D and A, B, C, D. So, yeah, 4 sites here. This diagonal element is 1. This is the data given to us in the numerical. You fill this by the reciprocal values. You fill these values by shifting using the HP scale, and then correspondingly fill the rest of the values by reciprocal. The procedure is similar. Take the sum of each columns, then normalize by dividing each entry into the column by the column sum for all the values. You will get the normalized matrix, and you take the average of these 4 to get the final weights of 4 alternatives under the criteria C1. Once this is done, you can check for the consistency using Ax equal to lambda x, where A is this matrix, the originally which you made from the table, and then x is the weights which are calculated. You do the multiplication of this matrix, you get Ax equated to lambda x, and lambda would be this divided by this. So, you get 4 values of lambda. The average of it would be something close to 4 because it is a 4 by 4 matrix. Consistency index, it is calculated by lambda max minus n by n minus 1, where n is equal to 4 here. Okay. So, it is 0.039, and consistency ratio is Ci by Ri. Random index for 4 by 4 matrix is 0.89. So, using that, so it is acceptable because it is less than 0.1. Just like we did for criteria 1, we can do for criteria 2, groundwater risk, 4 by 4 matrix. This data is given to us in the numerical. Do the column sums, normalize the matrix, take the average to get the weights, and then for consistency, check for Ax equal to lambda x, where lambda would be given 4 values. Average of this would give you lambda max, consistency index and consistency ratio. So, since we had filled the remaining matrix using the first column data, using rational shifting based on AHP scale, all the metrics are going to be consistent most of the time. So, it is consistent. For C3, land cost, again 4 by 4 matrix, normalize, weight, check for consistency, and it is consistent. For accessibility, criteria number 4, follow the same procedure, only the numbers would change, right, and you will see it is consistent. And the last criteria of environmental sensitivity, where following the same procedure you get the weights of 4 sites under the criteria of environmental sensitivity, and when you check for its consistency, it comes out to be consistent as consistency ratio is less than 0.065. Now, so what we have done? We have already evaluated the weights for the criteria and checked for their consistency. Then we have evaluated the alternatives based on each criteria and checked for their consistency also. So, final step is synthesis of scores and the ranking. So, these are the 5 matrices of 4 by 4 that we solved for each of the criteria. Those gave us these 5 columns. Okay. So, it is the scores of each site under each criteria, and the next value is the criteria's weights. 5 criteria have this much weightage. So, now this is the matrix of 4 by 5 and this is the matrix of 5 by 1. So, when we try to multiply these two matrices, the final matrix would be 4 by 1. Okay. So, this row into this column will give us the final score. So, it is 0.057 into 0.3 plus this into second value, third value into third value, fourth into fourth plus fifth into fifth value. Summation of these products would give us this score. Similarly, for side B, it will be row number 2 into entire column of the criteria weight. For side C, row number 3 into entire column of the criteria weight, and for side D it will be row 4 into entire column of the criteria weight. Now, if you look at the scores, which of the site is ranking first? Obviously, site B is ranking best, followed by site D, site C, and the site A is the worst site. So, first, second, third, fourth would be the rank that we would be giving it to those sites. So, if you have to do the interpretation, the first interpretation that can be done from the criteria weight, the highest priority or importance is given to groundwater risk, that is criteria number 2, followed by environmental sensitivity, this is criteria number 5. That is a inference from the criteria weight. Okay. Second, from the site scores, obviously site B is the most preferred site and second preferred site would be site D. Okay. Now, why site B is coming out to be the first? Because site B is ranking highest or scoring highest in the criteria having highest importance. So, groundwater risk, it is 48% importance and site B scores significantly higher than all other sites in this particular criteria. Now, why site D came out to be the best, second best? Because site D scored like at the third rank, it is in the under criteria C2, but it is first exceeding by all 3 other sites in criteria number 1, which is not the lowest weight, okay, but somewhere in the moderate range it is important, and in a moderate criteria it is having a very high score. Okay. So, these are the reasons why site D came out to be the second, and so all the judgments were also found to be consistent, because for each of these matrices we checked the consistency and the criteria of consistency was like followed, which is consistency ratio less than 0.1. It means all the judgments which were made in this numerical or in this case study, they were found to be consistent. So, these are the interpretations or inferences from the results or the final scores of AHP that we got from this case study. So, we solved for the criteria first, then for alternatives under each criteria, then got the final scores, rank, and then provide the justification for the observed ranks. So, that is how we can apply AHP to multiple numericals wherever there are multiple options among which we have to choose, and these options or the choice of these options would depend on number of criteria. Some of them may be quantitative, some of them may be qualitative. But irrespective of how the criteria are, ultimately for pairwise comparison matrix, we will need the judgment based priorities or importances, preferably in the form of scale like from 1 by 9 to 9, that is the AHP scale, so that it becomes easier to proceed forward with the AHP framework and steps and get this final data. So, as I mentioned earlier also, you can use this approximation method using pen, paper and calculator, or use Excel sheet, and if you have to use rigorous method, you may write your own code in any programming language like C, Fortran, MATLAB, or there are some online AHP tools also like online links where you just enter the matrix, the pairwise comparison matrix data, and it will give you the final weights, the consistency index ratio, and it will check for the consistency whether it is consistent or not. It can also give you the final scores. Okay. So, with that we will stop here. Thank you.